how do you take these just almost overwhelming amounts of new data and use it in a sense that is not overwhelming human operators in the way that we have in the past? It almost strikes me as that you have to kind of progressively take human analysis a little bit out of the equation here, which makes people nervous, and certainly some of the models are only as good as the data they're trained on. So there's possibilities there for errors, and certainly in terms of changing weather patterns that we haven't seen before. So how do you sort of square that circle?
So absolutely, and I think the key, you touched on really good points. So one really important factor is really to understand the context at which your users operate, right? So I travel a ton to Africa, for example. And when I go there, I spend time with farmers who live outside of cities, and not in kind of what we are used to. And it's really important to go there and kind of see what they have, what they care about, what kind of weather they care about, and what time frame, what parameters they care about, and what access they have. In some cases, they only have a feature phone, not even a smartphone, and solving backwards from that. So you say, well, I need a system that can send a single sentence SMS in some, uh, pretty um, uncommonly used language to that region so that they can understand and act on it. So that's a huge part of the solution. But I do want to touch on the data because, we have this, I think it's a false assumption that we have too much data.
Mm.
Marshall talk about GPM, the gap that GPM was trying to solve, which we are sort of taking the torch and moving forward with it, is one of perhaps the biggest gap we still have in atmospheric measurements. We have maybe 10% of the globe with reasonable precipitation measurements, precipitation being one of the most important weather parameters ever. That cannot be solved from the ground because we can't deploy, thousands of more radars. It's an 8 years old technology. It's kind of where it's going to get. But it also cannot be solved with billion-dollar satellites because you need a lot of them. And if they're costing $1 billion, that can't scale. So
Right.
what we're doing is we're taking science that NASA proved, and that's another really great example of government and private sector sort of collaborating. The science of measuring precipitation from space was proven by NASA decades ago. Marshall was part of that mission, but they didn't really care or worked on like, well, let's get the cost down to, few dollars per scan versus many thousands of dollars. That's what we're doing. And so we're taking that same technology, shrinking the size of the instrument, shrinking the cost significantly so that we can get enough data that actually makes it useful for the farmers so we can get rid of, the man in the loop and we don't need all this interpretation.